Here we see a geosynthetic panel drain being used adjacent to the road to act as a road edge drain. As the rain falls on the road, it is moved to the edges by the camber of the road and the sealing layer, and the road edge drain then moves the water away so that it does not enter the base layers and weaken the road. Here we see a geosynthetic sheet drain being placed behind a bridge abutment to move the water down and away from the structure. By minimizing the water behind the abutment, the engineer can lessen the imposed load by reducing the poor water pressure acting on the wall. It also means that there is no water leaking through the wall and staining the visible face of the abutment. Landfills also utilize geosynthetics to perform a drainage function, as controlling the movement of leachate and water within and around a landfill is a key design issue. In landfills, the geosynthetic drainage layers are wide rolls and will help move the leachate to collection points that will assist the engineer in removing the leachate from the structure without contaminating the surrounding groundwater. Geosynthetics allow the passage of fluids from within a soil while preventing loss of soil particles. For example, a geotextile liner of a traditional soil drain allows the water to enter the drain, but prevents fine soil particles from clogging the drain. Design engineers need to make decisions regarding pore size and permeability of the geotextile relative to the soil grading. The traditional system involves layers of graded aggregate, which filters the soil particles out as the water passes through, but a geosynthetic layer performs the same function in a simple way at a reduced cost. The most simple example is a French drain, where the geotextile is placed around the trench to prevent the surrounding soil from entering the trench and clogging the drain. These types of drains are typically used adjacent to roads and require the pipe in the middle to collect any water entering the system, such as runoff from the road surface. As such, the geotextile needs to prevent soil from entering the drain and clogging it. As this then means that the water cannot be drained and will enter the road formation and reduce the road's performance. Engineers need to ensure that the pore size and permeability of the geosynthetics material is appropriate for use with the surrounding soil. Geosynthetics prevent the intermixing of two dissimilar geotechnical materials, soils. Example 1. A geotextile laid at the bottom of a weak road formation separates the underlying in situ soil from the imported road base material. It is important to separate the two soil layers to prevent migration of fine particles from beneath into the road formation, which could weaken the road and reduce its life expectancy. Example 2. A geotextile laid under a rock wall on a beach prevents the sand from being washed out. This is important to maintain the stability and performance of rock walls in storm conditions. The separation function performed by geosynthetics is a very common requirement in road construction. By placing a geotextile at the base of the road formation, the underlying soils do not pass through the geotextile and mix with the aggregate layers. There are generally guidelines for specifying the separation layer within roads, as the selection of the grade of geotextile depends upon the soil below and the nature of the road. For example, is it a highway or rural road? Here you can see the rock being placed on top of the geotextile in the rock seawall. By separating the sand from moving into the rock seawall as the waves surge in and out of the rocks, the engineer ensures that there are no voids created behind the wall. which ensures the rocks are stable and perform as designed. Note that engineers need to ensure that the geosynthetic material can withstand any installation damage, such as when large rocks are dropped from height onto the geosynthetic material. The tensile properties of a geosynthetic resist stresses and contain deformations. It makes the soil stronger. Examples include a geogrid behind a retaining wall allows close vertical construction at a much reduced cost compared to a mass gravity retaining wall. Soil reinforcement products reduce the depth of required excavation when building on weak soils. This often applies in embankments, roads, and port facilities. Design engineers need to make decisions around load capacity, strength, durability, and allowable deformation. Here is an example of a geosynthetic reinforcement layer being used at the base of an embankment being built on weak soils. The reinforcing layer helps strengthen the base of the structure and allows the structure to be built faster or at reduced cost compared to alternative solutions, such as deep excavations or piling, whilst remaining within the allowable settlements. Controlling settlements is a major part of geotechnical design. Retaining walls commonly use geosynthetic reinforcing layers, as they allow near vertical faces to be built at reduced cost, compared to the traditional manner of mass gravity structures, i.e. large, thick structures which remain in place through their heavy mass. When designing, engineers need to understand how the functions of different geosynthetics meet the requirements of their project. Many geosynthetic products are available to perform these functions. In the next section, we will introduce the main product categories. A range of geosynthetic products have reset time and cost benchmarks for project delivery. Additionally, some projects that previously were simply not possible are now viable through the use of geosynthetics. Whilst there are many geosynthetic product categories, there are 6 core product categories that we will examine: geotextiles, geogrids, geosynthetic clay liners, geomembranes, drainage products, erosion products. Geotextiles are the most common geosynthetic category used widely in most earth-moving activities, such as roads, mines, ports, and so on. A geotextile is simply a textile designed for use in contact with soil and water. When geotextiles are used in civil constructions, they significantly reduce the need for excavation and importation of fill material. For example, instead of using a thick granular soil drainage layer, one can use a single thin layer of geotextile material. The geotextile allows the water to drain away while retaining the fine soil particles. In general, geotextiles can perform 4 major functions: separation, reinforcement, drainage, and filtration.